So let's continue with question 5. A red spinner has 4 sides labeled 1, 2, 3, 4. When the spinner is spun, the score is the number of the sides which lands. A random variable x denotes the score. The probability distribution table for x is given below. So the random variable x taking on 1, we have 0.28, 2 we have p, 3 we have 2p, and 4 we have 3p. So they are saying show that the probability sure P is 0.12. So you need to know that the sum of the probabilities is 1. So add them and equate them to 1 and make your P the subject, and you end up having your P as 0.12. Then part B says the fair blue spinner and the fair green spinner each have 4 sides labeled 1, 2, 3, 4. All the 3 spinners are spun at the same time. What does this tell us? When they say fair, it means that the chances are equal for 1, 2, 3, 4, and so it means taking on 1 is a quarter, 2 a quarter, 3 a quarter, and 4 a quarter. Because they are fair, they are not biased, the probabilities are the same. So I'm saying find the probability that the sum of the 3 scores is 4 or less. So it means when you add the values that are portrayed on both the 3, it should either be 4 and it can be 3. 3 is the list where each one shows 1, 1, 1. So we can have 2, 1, 1 and look at different arrangements where we can have 1, 1, 2 and 1, 2, 1. So the probability of a red showing us 2 is 0.12. So for green and blue, the probability is the same. That's why we have 0.25 times 0.25. Having the red one giving us 1 is 0.28. Then 1 on green and blue, 0.25 squared. And when you add all these up together, you end up having 0.04. So we are supposed to know how we get a 4 or a 3. So you could have shortlisted. So in statistics 1, listing is a proper technique. You'd have put down the different possibilities in which we can have the sum on all the 3 being 4 or being 3, and they are here, like you can see them. This one took a lot of marks, and it says find the probability that the product, so here they're talking about product, meaning when you multiply them, you should have 4 or less, meaning when you multiply all the numbers portrayed by those spinners, we should have 4, we should have 3, we should have 2, and we should have 1. But the question says, find the probability that the product of the 3 squares is 4 or less, given that x is odd. X is so the condition here is that the R must show odd. And for R to be odd, either it is showing 1 or 3. That's why here on my working, on R, I only have 1 and 3, because that is the only way you can have R being odd. And then the rest can have 1, 1, you can have 1, 2. So you must have listed all these and then just multiply their probabilities. Remembering that for R, the probabilities are not the same, they are in the table. And then for B and G, they are all 0.25, and that's all. So here, when they say the probability that the product of the 3 scores is 4 or less, it means that actually R, which is a random variable, X only has odd numbers. So from the definition of conditional probability, if you're dealing with conditional probability, the condition is X is odd. So simply on our numerator, we shall have product of the 3 scores being 4 or less and X is odd over the probability of X being odd. So how do you get probability of 4 or less and X is odd? You list the different possibilities in which we can have the product being 4, 3, 2, and 1, and you add them up together over the probability of X being odd. So X being odd, it means it is taking on 1 or 3, and probability of 1 in the random variable X 0.28, and 3 is 2p, and we had already gotten p, and we just have to substitute. So in conditional probability, we shall have on the numerator the product of 4 or less given X is odd over the probability of x being odd and get your answer. So we come to question 6. Question 6 is about permutations and combination. So we are told that in a restaurant the tables are rectangular. Each table sits 4 people, 2 along each of the longer sides of the table. 8 friends have booked 2 tables, X and Y. Rajid, Sue and Tan are 3 of these friends. 8 friends will be divided into the group of 4, 1 group for the table X and 1 group for table Y. Find the number of ways in which this can be done if Rajid and Sue must sit at the same table as each other and Tan must sit at the other table. So you look at 2 different possibilities where Sue and Rajid are sitting on X, or Sue and Rajid are sitting in Y. So how can we, so if we have Sue and Rajid on table X, it means in the remaining 2 seats are empty, so it means Tan will be seated on the other side. So Tan goes to this other side. So it means from the other remaining 5 people, we need to choose 2 to occupy table table X, meaning the other rest 3 will come and occupy table Y. Or if we have Tan on table X and Sue and Rajid on table Y, out of the 5 we can choose 3 to come and be on table X, and then the other 2 are left we choose and they go to table Y. So that's how that could be done. That's how we could find the number of ways in which that arrangement can be done. So you look at where Rashid and Sue and table X, meaning Tan was on the other side. So in the remaining 5, we need to choose 2 to come and occupy X, and the other 3 will come and occupy Y. So where we have Tan on table X, it means Sue and Rashid would be on the other table Y. So how can we have the other 3 come and join Tan? It is 5 combination 3, and the other 2 they will join Y, and then you add them. So here they're saying when the friends arrive at a restaurant, Rajida and Sue now decide to sit at table X on the same side as each other. Tan decides that he does not mind at which table he sits. So now this time around here, so on table X, we are told that Rajida and Sue decide to sit on table X on one side. Either they can sit on this side here, or they can sit here, this side. They can either sit here or they can sit here. That's where I have 2 possibilities. Then also in their sitting, we can have them arranged in we can have either Rajid first, then Sue or Rajid, or Sue or Rajid. So that can also be done in 2 ways. So whichever same side they have decided to sit in, remember the other 2, if they sit in the front, for example, if I make Tan to be my front, if they sit in the front, then it means that these 2 spaces are empty. So out of the 6, because we are told that Tan doesn't mind whichever or wherever he will sit. So out of the 6, we need to choose 2 to come and occupy this space here and this space here. And those 2 can be arranged as 6 combination 2 times 2. Yes, factorial. Then the other remaining 4, we can choose them and arrange them. So that's how it was done. So also instead of you doing this, you could have done times 4 factorial. Or I could have said 4 permutation 4. Because the key word is arrange. How can you have them seated? Different seating arrangements, meaning order here matters. So you look at where we have Sue and Rajid in the front. Either they can be in the front here or they can be here. I call this one to be the back. So there are two ways we can have that done. Also in their sitting, we can have Rashid and Sue or Sue and Rashid. Also two way. Then how can we occupy the other two spaces? In the remaining six, because they said Tan doesn't mind wherever he sits. So we can say six combination two. So we can choose from the six remaining to occupy the other remaining two spaces and can be arranged in two factorial ways. Then the other one on table Y, you can choose and arrange them, or they can be arranged in 4 factorial or 4 permutation form. So that's how it was supposed to be done, and you get your answer. And then lastly, as they leave the restaurant, the 8 friends stand in a line for a photograph. Find the number of different arrangements if Rashid and Sue stand next to each other, but neither at the end of the line. So meaning they are together. So you can have, this is the first space they can occupy. So how do we arrange the rest? So it is 1, 2, 3, 4, 5, 6, meaning the rest can be arranged in 6 factorial ways. Times, because when we take R and S to be together, it is like 1, it is taken as, the rest can be arranged. So these ones are together. They cannot take on this space, and then we arrange the rest as 1, 2, 3, 4, 5, 6, which is 6 factorial. But these two guys can be arranged in 2 factorial ways. Either we have R, S, or SR. That's why I said we times 2 factorial. And remember, either they can be together here, or they can be in this position, or in that position, or in that position, or in that position. And we see how many places they can, because they said they are neither at the end of the line, and this can be done in 5 ways. You first put them together and see how the rest can be arranged. So if R and S are there, it means the rest of the people can be arranged in 6 factorial ways. They can be arranged in 6 factorial ways. But then R and S, we can have Rajid and Sue, or we can have Sue and Rajid. That's why we say times 2 factorial. But we see we can have them in how many positions? In 5 different positions. And when you work out this, you end up having your answer as 7,200 ways in which that can be done. So you needed to first look at, just like the way I did it, try to draw line. Others try to use different forms of doing it, but look at different positions that can be occupied by them. There are 5 in where they are both at neither the end. So if they are in the first position, which is the second and the third, the rest, you look at the way that can be arranged, and you've seen clearly that the rest will be arranged in 6 factorial ways. So 6 factorial ways times 2 factorial, and we've seen that Rajid and Sue could occupy 5 positions where they are at neither end. Yeah, please subscribe if you've not subscribed for more Cambridge math help.